Hello, I'm Ryan Young. Today we're doing Module 26110, Basic Electrical Construction Drawings. Let's get started. 26110, Basic Electrical Construction Drawings. Successful completion of this module prepares you to do the following. Explain how to interpret construction drawings, explain how to measure items on scale drawings, identify information on electrical drawings, and describe how electricians use specifications. There will be some performance tasks your instructor will want you to do. Overview. Have you ever seen a site plan? How about electrical drawings? These are both construction documents. Approved construction plans include these documents as well as project specifications such as floor plans, detail drawings, lighting plans, power riser diagrams, and schedules. These plans, along with the contractor's bid, are legal documents. As a result, everyone working on a project must follow and maintain construction documents. This module describes how to read and interpret drawings used by electricians. 1.0.0 Construction Drawings. Explain how to interpret construction drawings, describe information found in drawing blocks, identify information found on different types of drawings, explain how to interpret drafting lines. Says, for most construction projects, the architect prepares a complete set of working drawings and specifications. Each page has a set, in a set is called a sheet. Drawing sheets usually include a site plan, a floor plan, an elevation drawing, and a section view. So let's take a look at what these are. A site plan is a drawing showing the location of one or more buildings on a building site. Such drawings frequently show topographical lines, electrical and communication lines, water and sewer lines, sidewalks, driveways, and similar information. These site plans are drawn on a huge scale. In other words, they're going to say 1 inch equals 50 feet, so that you can fit a whole city block on one sheet of paper. So the site plan actually shows the city block, or it shows the lot where the building sits. It shows the orientation of that building to true north, and it shows utility features. It shows street lights. It shows traffic signals, things like that. A floor plan is a drawing of a building as if the building was cut through horizontally at about window level with the top portion removed. The floor plan is what would appear if the remaining structure were viewed from above. So most of our drawings are floor plans. It shows what we need to put in the walls as far as receptacles and switches. When you get to a reflected ceiling plan, then you see lighting fixtures that are in the ceiling. A sectional view, cutaway drawing that shows the inside of an object or a building. Sometimes the architect wants us to know what the details of the inside of a wall look like, so they'll do a section view where they literally take a cutting of that wall and they draw what it looks like if we could see inside that wall. It's a sectional view. A detailed drawing and a large detailed view taken from an area of a drawing that shows is shown in a separate view, so they can get much closer in a detailed drawing. If you're using a scale of 1/4 inch equals 1 foot, and you can see a couple of rooms of the building, well, they might want you to take special notice of a particular cabinet or duct work or what have you, and they'll do a detailed drawing of that area where 1.5 inches might equal a foot, and that way they can show you in much greater detail a smaller area. So for larger projects, consulting engineers prepare the structural, electrical, and mechanical drawings. Mechanical drawings might include pipe fitting, instrumentation, plumbing, heating, ventilation, and air conditioning. As an electrician, you'll review construction drawings sets on almost all jobs. It's important that you know how to read them so you can do your work correctly and efficiently. In this section, you'll learn how to identify and read different types of construction documents. let's see here, 1.1.0 drawing set information. Let's see here. It says in the building construction industry, each firm prepares construction drawings or blueprints. Let's take a look at what they mean by blueprint. Exact copies or reproductions of original drawings. At one time, the drawings were drawn with graphite pencil, and then they were transferred chemically to another sheet of paper that would turn the paper purple. And wherever the graphite lines were, where the pencil drawing was of the walls and the numbers and all of the information, it would leave behind the white paper. So there were white lines on a dark purple or blue background, hence the term blueprint. Nowadays, everything's done with computers, so it's all black text on white background, but we still call them blueprints. Always treat drawings with care. It's best to keep 2 sets, one in the office and one for the field use. Be sure to use the most current revision after you use a sheet from a set of drawings. If the sheet is folded, refold the sheet with the title block facing up. It says a good place to start with information found on each drawing sometimes is called the block. This information tells the origin, identification, content, use, scale, and revision history of the drawing or sheet. Every drawing has an area reserved for one or more blocks. Usually it's on the right-hand side of the sheet. It'll tell you the title block and what so forth. On a drawing, the relationship between the object's actual size and the drawn size is its scale. Scale also refers to the measuring tool used to determine this relationship. So we're not going to draw a set of prints that is a one-to-one recreation of the building. If we did that, the blueprint would be the size of the floor plan of the building. So we use scale. You say an eighth of an inch is going to equal 1 foot. So every eighth of an inch on the drawing, it equals 1 foot in the real world. So every inch equals 8 feet. That way we can draw a large building on a small area. Title block 1.1.1. This is a highlight. It says some drawing sheets also have a revision block near the title block and or an approval block. So the type and size of title blocks vary depending on who prepared the drawings. It says there might be an architect's title block and an engineer's title block. Basically, the title block tells you the name of the project, the address of the project, and this is telling who the architect is and who the engineer is in their title blocks. Here's the seal from the county saying that the blueprints have been looked over and approved for construction. Each firm uses its own particular method of organizing and numbering drawings. Check the table of contents or legend in a drawing before for a key of the symbols, notations, and other specific information marking used on that set. In general, the title block of an electrical drawing should contain the following information: project name, address, client name, the architectural firm, professional engineer, drawing date, scale, initials of the drafter, checker, and designer, the job number, the sheet number, the general description of the drawing. So here's E1, that's the sheet. All of the electrical prints will start with the letter E, and then they'll be numbered in sequential order: E1, E2, 3, 4, 5. Here's G. Lewis Craig Architect. Here's District Home Laundry Building, Augusta County, Virginia. That's the site name, and it tells you the date and the person who transferred the drawing, and it was checked by and revised by. If it's revised, there should be a revision block telling you how many times it's been revised and the dates of those revisions. Here's the engineer's title block: Engineering Associates Limited, Charlottesville and Laurie, Virginia. Drawn, checked, date, sheet number, E1 of 2. Here's a highlight. It says each time the drawing is changed, the revision number changes too. When you replace a drawing with a new revision, be sure to remove and file the old version. Don't just throw those old versions away, you keep them. Keep them because they're documents on the job, they're legal documents. 1.1.2 sheet numbers. Every sheet in a drawing set has a unique number, often known as a sheet number. Sheet number is usually found within the architect's title block. Figure 2, the sheet number is E1. This number usually follows the standardized form of a letter, a dash, or 2 letters, and 1, 2, 3, sometimes more numbers. First letter gives the discipline or craft, and the second, if used, gives the additional subdivisions within the discipline. When used, the first number is usually the type of sheet or the floor of a multi-story building. Numbers that follow are in sequential order, often with numbers being skipped to allow for changes or additions later. So C is for civil, S is for structural, A is architectural, I is interiors, P is plumbing, M is mechanical, E is electrical, Z is for shop drawings. And the first number, general usage, plans, elevations, sections, large scale, details. As an electrician, you'll work with sheets starting with an E, but you may often need to look at sheets for other crafts, such as plumbing and HVAC, and topics such as the overall site layout. It's important to know how to identify the drawings to make sure your work is in the right place and doesn't conflict with others' crafts. So yeah, when you look at the blueprints, you're not just going to segregate the electrical drawings, look at them, and ignore all the rest. You want to look at all the other crafts in the area, see what they're doing, check with their measurements. Sometimes there's a mistake. I've been on jobs where the reflected ceiling plan had a lighting fixture and there was a sprinkler head right in the center of the lighting fixture. So you have to move the lighting fixture. The sprinklers take precedent. 1.1.3 Approval Authorization. Approval Authorization records the date when a person checks the drawing for accuracy. The approval block is usually on each sheet along the bottom of the title block. Spaces in the approval block are initialized and dated to indicate approval of the drawings. So it says descriptions of the information included in an alternate approval block are as follows. Professional stamp, design supervisor, drawn by, checked by, approved by, and the owner's approval. Signature of the project owner or the owner's representative along with the date signed. It's very important to get the owner's approval because if there are changes to the blueprints and the owner comes back later and says, I didn't okay that, then there's going to be, someone's going to pay some money to put things right. So here's an example of an alternate approval block. 1.1.4 revision information. Sometimes electrical drawings must be redrawn or modified during construction. When this happens, it's extremely important to note all changes and include the date and the changes were made. This ensures everyone using the drawings has an up-to-date set. It's very important when you're working on a job that you're working from the latest drawing. If you have last week's drawing and there's been a change, you could go full steam ahead and pipe in for lighting fixtures that aren't there. And in a case like that, the electrical contractor is going to flip the bill. First time you look at a set of working drawings and written specifications for a job, check each page carefully for revisions or modifications. Always make sure you're using the most up-to-date set of drawings. Most of the time when there's a revision to a drawing, they send out the new revisions to all the crafts and they have you update your master set of prints. And you take those old prints that have been revised and you file them away. Here it says otherwise clearly mark the old sheet with the text obsolete drawing, do not use. Taking time to make sure you're using the most current drawings can save time and expense. It says in some situations, sufficient space is left near the title block for dates and descriptions of revisions as shown in Figure 4. In other cases, a revision block is provided again near the title block as shown in Figure 5. The area on the drawing where the revision has been made will often be outlined with a cloud shape. So they'll go through the revised drawing and they'll put a little cloud around it. You'll see it, it'll stand out. So here's the revision block, tells you what's been revised, who drew it, who approved it, and the date that it was changed. Using a legend, 1.1.5. The legend block shows the symbols or lines used in a drawing, sometimes called the symbols used or symbols list. The legend may be anywhere on the sheet, but it usually lists the symbols or lines in a column on the left and their meanings in a column on the right. For a drawing containing only tables such as a panel, schedule, a legend isn't needed. So here's a schedule. A schedule is a systematic method of presenting equipment lists on a drawing in tubular form. So you might have a door schedule or a window schedule or panel schedule. Why won't you get out of there? All right. Let's take a look at 1.2.0 drawing types. A plan is a drawing that is used the width and length dimensions. It depicts the object in terms of their positions on or above a specified surface, depending on the plan's intent and content. They're almost always site or floor plans. So here's a plan. It's a drawing made as though the viewer were looking straight down on an object from above. And a dimension is the size or measurement printed on a drawing. Views are drawings that use height as one dimension and either width or length as the other. Views are typically elevation or sectional drawings. A detail drawing is a small detailed portion of a larger drawing. Depending on what detail is shown, it can be a plan or a view drawing. A perspective drawing is a projection of a three-dimensional object onto a drawing's two-dimensional surface. It shows the relationships between different parts of the object. A lot of times that perspective drawing isn't included in the blueprints, but it'll be used as a sales tool to show people what the finished building will actually look like. 1.2.1 site plans. Well, new contour lines after grading, new and existing roadways, all utility lines, the drawing scale, a true north indicator, descriptive notes that identify the adjacent properties, land surveyor, and the date of the survey, a legend so everyone using the site plan can read the information. These are all things that might be included on a site plan. So here's a nice example of a site plan. Let me see if I can zoom in a little bit here. So we can see contour lines, and it shows the grading of this. So this is the top of a hill, and that hill is running down. I don't know if this is before grading or after. This may very well be before grading because you're going to want your parking lot to all be on the same level or stair-stepped. So you want people to be able to park on a relatively flat surface. You don't want them parking uphill or downhill. So I can't imagine that they'd leave the parking lot with elevations like this. And again, there is something that shows us true north. So north is here to our right. And you can see that this property is not a square, but it's more of a trapezoid. And the building sits on that property. True north is up here. So the building is sitting kind of northwest, southeast. Here's the parking lot in front of it. Okay. The Property and the topographic survey are not included in the drawing set. They're used to create the site plan included in the drawing set. To develop the site plan and design a building to fit the property, the architect and/or engineer need a property and topographic survey. The electrical engineer needs this information to locate existing electrical utilities, route the new service to the building, and provide outdoor lighting and circuits. It also shows where the existing public utilities are located, including electrical lines, sanitary sewer lines, gas lines, water supply lines, storm sewers, manholes, and telephone lines. Topographic survey shows the property lines and the physical characteristics of the land. To show the physical characteristics, it uses contour lines, notes, and symbols. The physical characteristics may include the direction of the land slope, whether the land is flat, hilly, wooded, swampy, high, or low. And here are those contour lines showing what it looked like before. I'd say that these are utilities. I don't know if this is reclaimed water. Let's see, I don't see any kind of there's not a legend on there, so we don't know. 1.2.2 floor plans. This is what a floor plan is. Basically, that they've cut the roof off of the building and we're looking straight down from above at all of the walls in this building. And they're always going to try to draw the building square with the page, even if that's not true north. Okay, so here's perspective view showing the section cuts. They cut this wall and the roof off just above the windows or almost to the very top of the windows. And then when they took that off, now we can see the walls. So here's what it looks like. Here is this building, this column, and here's the building, and they should have drawn this column. Resulting floor plan is what its remaining structure looks like when viewed from above. So here's the utility, the kitchen, dining room, bedroom number 2, bedroom number 1. Here's a bathroom, here's a living room, a vestibule, and a closet. Here's the carport, and here's a utility room that it has a spare toilet, but it also has the washer and dryer. Might have a water heater. Actually, this may not be a toilet. This might be the water heater and the furnace, and then the washer and dryer. Here are closets with bifold doors in the bedrooms. And then they've given us all the dimensions. If they didn't, we could use a scale ruler to scale this. It would tell us on the blueprint what the scale is. A reflected ceiling plan is a mirror image of the floor plan. This plan shows the objects on the ceiling, such as the architectural details, luminaires, etc., as well as the architectural locations of walls, windows, and doors. A typical reflected ceiling plan is shown in Figure 10. So here's your floor plan. And then when we go here, here's the reflected ceiling plan. Well, it's a shame this isn't the same drawing at all. They're using a different drawing here for the reflected ceiling plan. But yeah, this is too small. We can't get any detail at all. I was trying to show you that these are 2x2 grids, drop-in lay-in ceilings with 2x4 lay-in lights, but you really can't see any detail in that. It's too small. Right. 1.2.3 elevation views. An elevation view shows a building's exterior face, including the front and rear elevation. An architectural drawing showing the height and width, but not the depth, usually showing the front, rear, and sides of a building or project. So An elevation is that you're standing on the street looking at the house, and this is what the house looks like from the street. So it's literally the elevation of the walls. And here's the front door, here are the front windows. We said that this was the vestibule, and then the living room. And I think this is bedroom number 1, and there's a bathroom and a bedroom number 2 in the back. Here's the rear elevation. So this is showing that utility room. And this is off the dining room, and this is bedroom number 2. Look, they've even got a little hedge here, a little bush. Left and right elevations. Okay. So here's the front of the house, here's the rear of the house, here's that bush, the hedge. And then we've got bedroom number 1, bedroom number 2, and here's a vent in the attic. Here's the left elevation. Here's the carport, and this leads into the vestibule, and this is bedroom number 2. 1.2.4 sectional views. A section or sectional view, like the one shown in figure 13, is a cutaway that shows a structure's hidden parts. Sectional views typically illustrate floor levels and details of footings, foundations, walls, floors, ceilings, roof construction. So here's the sectional view. This is called a cut line, and it says that they took a saw and they cut this part of the building away, and you're standing on the ground and you're looking in the direction of this arrow. So from here, you're looking back toward the house this way, and here is that sectional view. This is what it looks like. This is the rafters in the attic, and here's the 2 walls. This is the back of the house, and this is the front of the house. This wall is this wall, and this wall is this wall. And then they want you to see a detail, so they even took a detail drawing, BA5, and it says that it's on sheet A5, and it's the detail B. So we'd have to go to sheet A5 and find detail B. Here's detail A. All right, there it is right there. This is showing you the outside wall, how it's bolted. It's block, it's bolted to the header. And then they have insulation. They have your rafters and your shingles. Very good. And this is the part that they took off of the house. They cut that front half off. And look, the arrows are pointing in the direction that we're viewing, the cut view. This is highlighted. It says the place on the plan or elevation showing where the imaginary cut has been made is indicated by a section line, usually a dashed line. Special symbol used at the end of the section line is made from a circle and an overlapping triangle. The triangle points in the direction you're looking in the sectional view. The circle identifies the section, such as section AA or section BB, and the drawing sheet the section is located on, if not on the current sheet. On the top of figure 13, sectional view AA is located on sheet A5 and is looking toward the right. If the section is on the same sheet as the drawing, the symbol at the end of the section lines is often abbreviated to a small arrow with an adjacent letter. So this is A detail, A on A5. So here's A on A5. And then this is B also on A5, which is here, B on A5. Okay. 1.2.5, a detail is an enlargement of a portion of the main drawing. On the main drawing, this portion is often bounded by a circle or other closed line shape. Close to this boundary line is a special symbol that refers to the associated detail. You can see this on the left side of figure 13 with detail B located on sheet A5. For a detail, there's no change in the direction of view. Special symbol doesn't have an arrow. Okay, very good. 1.3.0 drafting lines. Construction drawings use many types of drafting lines. These lines have different characteristics depending on what they're showing. For example, lines might have a different width or be dotted or dashed. That way you can know by sight what each line means. There's no standard for drafting lines. These lines may even change from drawing to drawing within a set. Always check the legend on each drawing sheet to make sure you know the meaning of each line. So here are a couple of lines. There's a light full line. A light full line is used for section lines, building backgrounds, and what are the object to be drawn as secondary to the system being shown. There's a medium full line. A medium full line is frequently used for lettering on drawings, may also be used for some drawing symbols, circuit lines, etc. A heavy full line is used for borders around the title block, schedules, or for lettering drawing titles. May also be used for some types of symbols. An extra heavy full line is used for border lines on an architectural engineering drawing. Sometimes letters and numbers will be embedded in the border line to enable quick location of a specific object on the drawing. Here's a center line. It's a dash and a dot, a dash and a dot. A center line is a broken line typically made up of alternately spaced long dashes and short dashes or dots. It indicates the centers of objects such as holes or pillars. Sometimes the center line indicates the dimensions of a finished floor. And here's a hidden line. It's a dashed line or a dotted line. A hidden line typically consists of a series of short dashes or dots that are closely and evenly spaced. It shows the edges of objects that are being behind others in a particular view. The object outlined by the hidden lines in the drawing is often fully pictured in another drawing. So here's a dimension line. The dimension line ends in arrows, and it has a dimension written as a number in the center of the line. Thin lines are used to show the extent and direction of dimensions. This is highlighted. The actual dimension is usually placed in a break inside the dimension line. Normal practice is to place the dimension lines outside the object's outline. However, it may sometimes be necessary to draw the dimensions inside the outline. Here's a break line. Short breaks and long breaks. These lines show where an object has been broken off to save space on the drawing or avoid visual interference with other drawing objects. So this might be a match line with another drawing to let you know that whatever we've drawn up here, if you go to this other drawing, you'll see what's drawn down here. Here's a match line with two dashes. A match line is used to show the position of the cutting plane. A match or cutting plane line is a heavy line with long dashes alternating with two short dashes. It's used on drawings of large structures to show where one sheet of the drawing stops and the next begins. A secondary line is frequently used to outline pieces of equipment or to indicate the reference points of a drawing that are secondary to the drawing's purpose. And then there's property line. Let's see here, extension lines. Extension lines just let you know what something's looking at. Extension lines are lightweight lines that start about 1/16 of an inch away from the edge of an object and extend out. They're commonly used to create boundaries for dimension lines. Dimension lines meet extension lines with arrowheads, slashes, or dots. So here's section lines. They're using these hash marks or these diagonals. These lines are often referred to as crosshatch lines. Drawn at a 45-degree angle, here's a highlight. It says these lines show the location of the section on the plan and where an object has been cut away to reveal the inside. Phantom lines are solid light lines that show where an object will be installed. A future door opening or a future piece of equipment can be shown with phantom lines. Okay. Section 1 review. I'll let you go over this and answer these questions. A drawing contains an area circled in a cloud shape. This information is often detailed in what? Which of the following shows the face of a building? And what type of line is used on a drawing of a large structure to show where one sheet of the drawing stops and the next begins? Okay, I'll meet up with you on the next video. Thanks.